Good afternoon. So what we're doing today is we're continuing working on our study guide. And so happens that 6 through 10 or even through 11 are the same types of, generally the same types of problems. So I'm going to go over these. I'm going to choose some people a little bit as we go forward. As you might be able to see that some of the polynomial functions sort of ratchet up degree of difficulty from third power to fourth power, and I think maybe even to fifth power. So it really takes some levels here. So number 6, finding all real roots. What are other ways we can say all real roots?
Zeros?
Yeah, so a synonym for roots is called zeros. So that's an important one. What other synonyms do we have?
X-intercept.
X-intercepts, yes. And so what you've done here, Ben and Addie, you have given us the perfect synonyms. Now there's one other word that's not exactly the same as these three, but is very similar and related to it. I'll tell you what it is. It's called a solution. And basically the distinction is this, that if you have one side of the equation equal to 0, then the zeros, x-intercepts, and roots are also solutions to that. Okay, so those four words are related. So if you have compiled in your mind someplace those four words, you can't go wrong with x-intercepts and polynomial function, or at least it's hard to. Okay? So now let's go about the process of solving by finding all real roots. So I want you to do that. I'll call on somebody here in another minute or so. How's that? You can see your paper okay, Addie?
I think I can.
We got Addie battling through some temporary blindness today.
Yes.
How did you like your birthday song? Did you like it?
It was very nice.
Good, good. We had some fun.
Yes.
It was a really good thing.
Thank you.
And I really like to see, one thing I really like to see is like Kim is working on her calculator a little bit to check.
I think I got this for you.
You got it? Let's go ahead and,
No, I don't know what to do.
okay. Let's go ahead and choose this.
Oh, no, never mind. I
So Gabby, you're the young woman
The
of
first time actually somewhat none of you, not really.
Sometimes it works out that way, Gabby. All right, what was your strategy, or how did you handle this?
So first, I kind of just went with the -2 and did the box thing.
So you tried x equals -2,
Yes, sir.
and then you went like this,
Yes.
and then what goes here?
It goes 1, 7, 14.
All right, good. So that comes down as 1,
Then
and then -2,
5,
5,
-10,
-10,
4,
4,
and then
-8. So what that tells us is that we have x plus 2 as a factor, right? Okay, good. And what do we do to factor this business out? You got x squared plus 5x plus 4, right? So that's going to be x plus 2. And what are these other things going to be here?
X plus 1 and
X plus 1 and x plus 4, does that look good? Yes, 4x, 1x, that looks good. Okay, so the solutions are going to be x is equal to what? Well, x is equal to negative 2, right? And what else? X is equal to?
I did x equals negative 1.
Negative 1. X equals negative 4. Did you check that in the calculator too?
That part I didn't get to.
You didn't get to it yet?
I didn't get to it.
Let's go to the calculator quickly. So we got x cubed plus 7x squared plus 14x plus 8. Oops. X cubed plus 7x squared. Is it plus 14x plus 8?
Yes.
So graph this, we should see all the things. Negative 4, negative 2, negative 1. They're all there, aren't they? Everybody is there.
Mr. G, I have a question.
Yes?
So whenever you're synthetically dividing, the number that you choose, like negative 2,
Yes.
is it always going to be a factor of the last digit? Like the 8? Now the last number?
So if you choose negative 2, is that negative 2 you're asking going to be a factor of this?
Factor of 8.
Like in the equation.
Like in here?
No, I mean like whenever you synthetically divide, you know, you have to like choose a number.
Okay.
We chose negative 2,
Yeah.
but like it can't be 3 or negative 3 because those aren't factors of 8.
Right, that's right.
Is that true?
Yeah, and what happens is 3 violates the rational roots theorem. How?
Yes.
Well, how it violates it is this, is that your potential list of zeros is going to be factors of, you're going to have plus or minus factors of 8 over factors of 1. So we're going to have plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. And so 3 isn't going to work out because that's not a potential rational zero, according to the rational roots theorem. Okay? And so, this is a good section today because we work on this. We're also going to be talking about a little bit later on something called the remainder theorem. We touched on it briefly in class, but we have a chance to really anchor it up here. So was that your question here?
No, I realize that like the number we divide by is always the factor of the last number.
Yeah, it is. It's gonna have to be
Because
in order to zero out, right? Yeah, so it's gonna have to be because of that. Yeah, so you see these commonalities. All right, good job. Thank you, Gabby. That's really good.
I don't know, I just don't know which number to like try first. I'm gonna waste more time.
So I want you to look at number 7. I'll call on somebody for number 7 here in just a couple of minutes.
But then after all, I don't know.
Okay,
Mr. Fletcher, can you come back to the office, please?
sure, I'll be right there. Okay, let's go ahead and shoot somebody.
I think so. I'm trying to figure out like after I fix this one.
Looks like we're gonna get Bryce, is that right, Bryce? Okay, Bryce, what do you think?
I haven't even found the thing that's synthetically divided by.
I know.
Yeah, okay.
I want to demonstrate.
Now, here, what happens is, this wraps up a little, there's a little complexity going on here. Because we don't have like a 1x cubed. So what we have is we have our potential list of zeros. It's going to be plus or minus factors of our numerator over factors of this thing here. So 1, 2, 4.
Wait, where did you get that?
Wait, what?
Okay.
Factors of what number are 1 and 3 factors of? Oh, okay.
So that's where that comes from, right?
Okay, what about the denominator?
Yeah, your denominator is going to come from here, see?
Okay.
Yeah, so what it is, this has a little more complexity because of the possibility of, and you have like fractional zeros. So what you're going to have is plus or minus 1, plus or minus 3, and then you have to worry about these fractions here. So you get 1 over 2, uh, 1 over 4, and now 3 over 2, and then we have 3 over 4. All right. Now, this is where I start exercising my praying skills. Why do you think I'm interested in praying about a problem like this?
So you don't have to go through every one of them.
What do you say?
You don't have to go through every one of those.
Yeah, so I don't have to go through every one of them. And also, and related to that, I want to get the easy ones, right?
Yeah.
So I'm praying that the easy one works, because if I have an easy one that works, I probably can factor the rest of it out. So I don't know what looks like an easy one to you.
-1.
-1 looks like an easy one to me. Okay, and actually, I would try -1, +1, and -3, +3 before I dealt with those others. So let's go ahead. You say, Bryce, you said -1, is that what you said?
Yeah.
So 4. I can see it now. Is that -3?
No, just 3.
As far as +3, +3, okay. I can see it now, Gabby going home tonight. Dad, my Algebra 2 teacher prays for answers. All right. So now we take this times this, we get -4. And we get -8 here, right? And so we get 8 here. And then 3 here. And then -3. So what just happened, class?
You could go home.
Prayer was answered. Everything is good. Well, until we run into the next roadblock, which can happen. So now we have x plus 1, Bryce, is that right?
Yes.
So x plus 1 is a factor, and now we got 4x squared left minus 8x plus 3. And so now we have some more complexity, and if we wanted to, we could try out some of these other zeros, couldn't we?
Yeah.
But once we get to a quadratic trinomial, I don't think I need to do that, right? I can try factoring methods here. So what's going to be a good factoring of this thing here?
Okay, wouldn't it be x plus 1 and then x plus 4 and then x minus 1?
X plus 4,
You need a 3.
Yeah, 3.
What about X?
what'd you get?
X method. I did the X method.
Oh, you did it? So Addie said she did an X method on this thing. I'm going to go ahead and do this because I have confidence in Addie today for some unknown reason. Okay, so 12 goes here, right?
Yeah.
And then negative 8 goes here.
Mm-hmm.
So what numbers you come up with, Addie?
-2 and -6.
So -2, -6. And then you divide it by
4.
4. So over here, it looks like -1/2. And over here looks like -3/2. So we have like x minus 1/2, and then x minus 3/2. Does that look right?
Yeah.
So that's going to be x plus 1, that 2x minus 1, and then 2x minus 3. And what are the solutions going to be? X is equal to -1. What else? X is equal to 1/2. X is equal to 3/2. Okay, so that should get us all that, right? Okay. It's not that bad, is it?
No, it's hard for me to figure out which ones to try when I'm doing synthetic division.
Oh yeah, that's right. So what you say is exactly right. Now one thing we're going to get into, something a little bit later today that we touched on briefly in this class, is something called the remainder theorem. And a remainder theorem can help sort of be a guidepost to be more sure we're on the right track. Who wants to be on the right track?
Me.
Oh.
All right, so now
Yeah, the next one I can't.
this one here.
Yeah, I tried it, Mr. Jan.
You tried this one?
I can't find a number to
Okay.
that works.
What I want to do is I want to introduce to an enlightened mind something called the remainder theorem. And what you can do is your remainder theorem allows you to try out numbers quickly without having to synthetically divide the whole thing. And the way it works out is this, that if you plug in a number 1, you say let x equals 1, then f of 1 is equal to 1 cubed plus 3 times 1 minus 4. And so what's 1 plus 3 minus 4?
Wait, isn't it supposed to be squared?
0.
Yeah, this is squared here, huh? Yeah. But what's this going to be? 1 plus 3 minus 4 is 0. So what this is called the use of the remainder theorem. Because I plugged in 1 and got 0 as a remainder, right? So
it's just
now-
putting in numbers? Well,
So now what I can do is I can go ahead, and so now I'm super confident that 1 is going to work over here, okay? And something like this, where 1 is really easy to try, because all you're dealing with the number. You say, okay, that's 1 plus 3 minus 4. Now, when you take negative 1, you can get a little more complicated than that.
Right.
When you have 1 plus 3 minus 4, that's 0. That's that. So you know that's going to be that. So now, what you do is you take what you have left here. You have 1x squared plus 1x cubed plus 3x squared plus 0x minus 4. And now you can just go down here, and you already know you're going to have a hit. And then you have 1 time, that's going to be 1, 4. 4 times 1, that's 4. That's 4. That's 4, 0. So what you have is you're going to have x. If x is 1, x minus 1 is the factor, right? And then you have x squared plus 4x plus 4. So you have everything. You have x minus 1. You have x plus 2.
Wait, isn't the plus 4x supposed to be plus 3x thing, or plus 3x?
I'm not sure.
On the, you have x squared plus 4x plus 4?
X squared plus 4x plus 4, right?
Okay, fine.
And this is a factor form of that. So what you have is you have x is equal to negative 1. It says include multiplicities. So that's multiplicity of 1. You have x is equal to negative 2. Actually, it's supposed to be x equals 1. X equals 1, multiplicity of 1. X equals negative 2, multiplicity of 2. And so now you can with this you can sketch pretty quickly, right? You have your x-intercepts of negative 2 and your x-intercept of 1. You know you have a cubic function here. So you're going to come up here. What's your multiplicity at x equals negative 2? 2, bounce. So when we come down here, and your multiplicity at x equals 1 is going to be 1. Like this. And so when you graph in a calculator, you should see all that, right?
So if it's greater than 1, then if the multiplicity is greater than 1, then it just bounces, and then if it's
If multiplicity is 2,
That's odd, isn't it?
or 4, or 6, or 8, then you bounce.
Oh, okay.
If it's 1, 3, 5, 7, 9,
It goes
it goes through.
Okay.
And so some good questions today. Some good exploration. I want you to look at number 9. And I'll choose somebody to help with number 9 in a brief moment. Okay. This one here, okay, we got a fourth power going on here. So that ratchets up your complexity a little bit. Let's see what we got going on here. We got Kim or Benny Z. Looks like Kim. Right, Kim, what do you think?
I did that thing, I don't know, and I got x equals plugged in 1 and it worked.
So you plugged in 1.
Yeah.
Okay, let's try that out. So you get 1 minus 6, that's -5. -5 plus 4, that's -1. -1 plus 6 is 5 minus 5. So x equals 1, that's going to be a deal, isn't it? And so that's just the way you did it, right?
Yeah.
Okay, very good. So let's go ahead and work that out. And so we get 1, was it 1 here?
Yeah.
And then 1, -6, 4, 6, -5. All right. So 1, that's 1, right?
And then -5.
5,
-5.
5, 1.
Wait. -1.
That's -1, right?
Yeah.
Okay, thanks, yeah. And this is going to be -1, 5, 5, 0, right? So we have is you already have x minus 1, and then you have x to the cubed minus 5x squared minus x plus 5. Okay, what did you do next on this guy?
I didn't get there.
You got here, but no
Yeah,
farther,
so-
is what you're saying?
And then you synthetically divide it again?
Yeah, so what number would you try the next time?
Well, I did the remainder theorem again, 1.
1? So you used 1 again?
Because -5 plus 5 is 0, and 1 plus -1 is 0.
Can you
Yeah,
do
so
negative?
1 minus 5, that's -4. -4 minus 1, that's -5 plus 5, that's 0, right? So it's the same thing all over again, isn't it? So let's go do that. But this time we have 1x cubed, we got -5x squared, we got -x, and we got 5, and tried 1 like this, right? So 1, 1, 1, that's going to be 1, -4, and this is going to be -4, -5, and -5, 0. So we have here is we have x minus 1, and yeah, so we have 2 of them, don't we? Because we did it here and here. And what we have left with here is we have x squared minus 4x minus 5, and that's going to be
X minus 5.
x minus 5, x plus 4,
1.
x plus 1. So here we have x equals 1, that's multiplicity of 2. We have x is equal to 5, that's multiplicity equals 1. And we have x is equal to -1, and that's multiplicity equals 1. Okay? So we have all those things here. Okay, so some good work there. And I'm thinking, a second here. So really that's it, right? On number 9.
Mr. G? Never mind. I thought I had a question, but I got it.
Okay. And so, so now 10 related, how many real roots does the function x to the 4th plus x cubed minus 5x squared plus x minus 6 have? How would you find that?
That is 4.
Well, the easiest way I would do it is right here in your calculator. So you take here, you take x to the fourth,
Right.
and then what are the other ones here? It's going to be
Plus x squared?
plus x squared
Yes.
Plus x cubed.
plus x cubed
Yeah.
plus x cubed. And what's the next one?
Minus 5x squared.
So minus 5x squared. And then
And then
plus x
Minus 6.
minus 6. Okay, we graph.
Oh,
So how many real roots do we have here? 2. So two real roots, x equals -3 and x equals 2, right? What kind of roots do we have left? If those are the 2 real roots, what kind of roots do we have remaining? We have non-real roots. Okay, so we got us a 4th power going here.
right.
So we have 2 non-real roots.
So is that where it bounces back up?
And essentially that's what it does, and if you look at what happens there on the y-axis,
So
that's kind of what happens at 0. Like if you added 6 to this, you would bounce right off of x equals 0. Do you see that?
Okay.
Yeah.